Welcome to CSEC Math. I am Sir Kumar, and today we will be focusing on area of simple plane figures. We would be looking at the definition of area, and we have 7 shapes that we're going to go through with the formula and then the application of using the formula to solve questions given. So the first thing we have to look at is, what is area? Area is the measure of surface. The unit of measurement is squared. For example, you have cm squared, meter squared, etc. Now, the measure of surface, what does this mean? So let's say you have a room and you would like to tile this room or cover this room. In order to do that, we have to calculate the area of this room. So when we're calculating the area, what we are finding actually is the measure of this entire surface here. So after finding the area, let's say you want to use tiles, you would then have to go and find the area of one of your tile and then divide the total area of this room by the area of one of your tile, and then that would tell you how many tiles you need to cover this room. So this is the application of area in a real life situation. Now, we find area of plane shapes. So what are plane shapes? A plane shape is a flat two-dimensional shape that is closed. The straight line that makes up the shape are called the sides, and the point they meet is called the vertex. Now, if you look at this, we have 1 straight side, 2 straight side, 3, and 4. And if you notice, where they meet this point is what we call the vertex. So as we go on and we go through the properties of plane shapes, you would hear me using the word sides and vertex. And in some cases, interior angles, which would be the angle inside of a shape. And then you would hear some of interior angles and so on. So some of the shapes that we'll be focusing on today are, you have the square, the rectangle, the triangle, the trapezium, the parallelogram, the rhombus, and the kite. Now, the circle is also a plane figure, but we will not be focusing on the circle in this section because there's a lot of parts to go with the circle. So the circle would be in another session, but for now these are the shapes we're going to be focusing on. Now we're going to go to each individual shape where we're going to look at the properties of each shape. We're going to state the formula to calculate the area of the shape, and then I'm going to work an example for you. The first shape that we'll be looking at is the square. So some basic properties of the square. The square is a 4-sided figure. All 4 sides of the square are equal. Each interior angle is 90 degrees, and the sum of interior angles is 360 degrees. To calculate the area of a square, the formula that we're going to be using is A is equals to L squared, where L represents the length of one side. Now, let's look at the example across here. So you have a square with 5 cm, and you have to calculate the area of the square above. The first thing you have to do is identify what is L. So we said that L is the length of one side. And since we said that all 4 sides are equal, if this side is 5, then here is also 5, here is 5, and the bottom is 5. So we know that L is 5 cm. Our formula is A is equals to L squared. Now, squared means that L is going to be multiplied by itself 2 times. Whatever the power is up here, we're multiplying the base by itself this number of times. So using our formula, let's substitute what is L. So A is equals to 5 cm squared. A is equals to, remember I said it's this base multiplied by itself 2 times. So it's going to be 5 multiplied by 5, which is going to give me 25 cm squared. And when we're working with area, our unit is always in squared. So if it's cm squared, meter squared, whatever unit they give you here, it's in squared in your answer. The second shape we'll be looking at is the rectangle. Some properties of the rectangle. The first one, a rectangle is a 4-sided figure. Opposite sides of a rectangle are parallel and equal. Parallel meaning they run alongside each other. and equal means that they have the same length. Each interior angle is 90 degrees, and the sum of interior angles is 360 degrees. The formula to calculate the area of a rectangle is A is equals to L times B, where L is the length and B is the breadth. In some cases, you would find L times W, which is length times width. So some persons would interchange breadth with width, but essentially it's the same formula, the same application. Now, let's look at an example. You have a rectangle here with sides 8 cm and 3 cm. We have to identify what is the length and what is the breadth. So, the longest side here is what we call the length, and the shortest side is what we call the breadth or the width. So, we say L is equals to 8 cm and B is equals to 3 cm. Now, we identify the parts of the formula. Let's state the formula. So, A is equals to length times breadth. A is equals to the length, which we identified as 8 cm, multiplied by the breadth, which is 3 cm. A is equals to 8 times 3 would give me 24, and cm times cm would give me cm squared, and this is how we end up with the unit. So the area of the rectangle above with length 8 cm and 3 cm is 24 cm squared. The third shape we would be looking at is a triangle. Some properties of the triangle are, you have one, triangle is a three-sided figure. The sum of the interior angles is 180 degrees, and it has 3 vertices. Remember earlier we said that the points are called the vertex, or in some cases when you have them more than one, we say vertices. Now, when looking at the area of a triangle, we have 3 methods of finding the area of a triangle. So the first one we'll be looking at is area is equals to half BH, where B is the base and H is the perpendicular height. Now, what does perpendicular mean? Perpendicular means when two straight lines come together to form a right angle. And if you look here, I have 3 applications of how we could identify the base and the perpendicular height. In some cases, they give you the height in the middle, and the line coming down, which is a straight line, and our base forms a right angle when these 2 lines meet. And if you notice here, I have the little right angle. Now, it's not always like this. Let's say the shape was turned a little. Then once you see this line in the middle coming down to one of these sides, and it forms a right angle, then the side that it connects to automatically becomes the base, and this is still our perpendicular height. Or in some cases, you have a plane triangle and they give you the height on the outside, which again, the straight line coming down, and if you extend this, it forms a right angle. So these are some of the cases of how they could give you the perpendicular height when finding the area of a triangle. Now let's look at the example across here. You have a triangle with a base of 5 centimeters and a height of 3 cm. Let's state what we're given. So B is equals to 5 cm and H is equals to 3 cm. Now let's use our formula and substitute these values and find the area of this triangle. So A is equals to a half B H. A is equals to a half B, which represents our base, and that is 5 cm, multiplied by our height, which is 3 cm. A is equals to a half. Order of operations, remember that we always solve our bracket first. So we work out what's in the bracket. 5 3s is going to give me 15 cm squared, and half of 15, or half multiplied by 15, is going to give me 7.5 cm squared. So 7.5 cm squared is the area of this triangle above. The second method to find the area of a triangle, we have what we call Herons Formula. And Herons Formula is in 2 parts. The first part is S is equals to A plus B plus C divided by 2. And then you have the area part is equals to S into S minus A, S minus B, S minus C, all under the square root. Now, S is what we call the semiperimeter, and A, B, and C are the sides of a triangle. So when you get a triangle with all 3 sides listed, this one you don't have a base and a height, you're given the length of 3 sides, we have to use the Herons formula. So let's look at an example of how we calculate the area using the Herons formula. So you have a triangle here with 3 sides. The first thing you have to do is let's label it. So let's call this A, let's call this B, and let's call this C. So we have to go and find our semi-perimeter. So S is equals to A plus B plus C divided by 2. S is equals to A, which is 12 cm, plus B, which is 22 cm, plus C, which is 16 cm. And we divide it by 2. S is equals to 12 plus 22 plus 16 is going to give me 50 cm divided by 2. And when we divide it, we're going to get 25 cm. So therefore, S is equals to 25 cm. Now S is very important to the next part of the question. So we found that S is 25 cm. Now we have to use this into our next formula. So A is equals to the square root of S into S minus A, S minus B, and S minus C. Now wherever S is, we're going to substitute 25, and A, B, and C would be the length of our 3 sides. So let's start substituting. A is equals to the square root of S, which is 25. In this step, I'm going to leave out the unit because it becomes a bit too long. So we're just working with our numbers. So S is equals to 25, open bracket, S, which is 25, minus A is 12. Next bracket, S minus B, S is 25, minus B, which is 22, and S minus C, S is 25, minus C, which is 16. So we have A is equals to the square root of 25. 25 minus 12 would give me 13. 25 minus 22 would give me 3, and 25 minus 16 would give me 9. Now, under this square root, the bracket means to multiply, so all the numbers here, we have to multiply them. So the area is equals to the square root of 25 times 13 times 3 times 9, and when you multiply them, that's going to give me 8,775. So when you have 8,775, to find our final answer, we square root 8,775, and that's going to give me 93.67. Remember I told you to leave out the unit, so let's add back our unit here. We know that area is in cm squared. So our answer is 93.67, and if you want to write in 1 decimal place, the area is 93.7 cm squared. So remember, when you're working area of a triangle and you're not given the base nor the height, but you're given the length of all 3 sides, you have to use this method, which is the Herons formula, to calculate the area of this triangle. So the third method to find the area of a triangle, we're going to get into a little bit of trigs here. So the formula is A is equals to half AB sine C, where A and B are sides of the triangle as given, and C is the included angle. So if you look here, we have A, B, and C is what we represent angles with. And the side that is opposite the angle B becomes the side B, and the side that is opposite the angle A becomes the side A. So these are the 2 included sides that we would be working with, and the angle. Now, this is the general formula, and it could be interchanged, where you're given not angle C, but you're given angle B or angle A, and then you interchange the first two parts. So let's look at an example of how we apply this formula to find the area of a triangle. So here you have a triangle with A, B, and C. So this is angle A, this is angle B. The side opposite angle A becomes side A, and the side opposite angle B becomes side B. So we have AB, and we have our angle that is included, which is C. So let's write down what we have. A is equals to 8 cm, B is equals to 12 cm, and the angle C is equals to 123 degrees. The little triangle, this little thing in front of the C, means angle. So let's use our formula and substitute our values. So A is equals to 1/2 into AB sine C. A is equals to 1/2. A is 8 cm. When you don't have a sign between these two variables, it means to multiply. So it's going to be 8 multiplied by B, which is 12 cm, sine the angle at C, which is 123 degrees. A is equals to 1/2 of, you multiply here, and this is going to give me 8 times 12 is 96 cm squared sine 123. Now at this point, you have to use a scientific calculator, and you're going to put in 96 sine 123. Let me take out the square so that it won't confuse you. So we're working with this. So you use the calculator and you put in 96 sine 123. So when you put that into the calculator, you're going to get A is equals to 1/2 of 77.99. A is equals to 1/2 of 77.99 is going to give me 38.95, and we're working in cm, so we put back our unit, and that's going to be cm squared. So when you're given two sides at an angle, remember you have to use the formula, which is 1/2 AB sine C, to find the area of a triangle. So let's recap the area of a triangle. We looked at 3 different formulas given 3 different scenarios. So I have 3 statements here, which is going to help you to identify when to use the formulas given. So when given the length of the base and the perpendicular height, this one, we're going to use the 1/2 BH formula, which is 1/2 base times height. And if you could remember from the examples, when you're given a triangle with the base, you look for the perpendicular height, which comes in the middle, or sometimes it's given on the outside. We use the 1/2 BH. Remember, perpendicular is when the two lines, straight lines, come together to form a 90-degree angle. The second scenario is when given the length of the 3 sides. So in this one, we use the Herons formula, and the Herons formula is S is equals to A plus B plus C divided by 2, and then further, A is equals to the square root of S into S minus A, S minus B, S minus C. And from the example, that's when you're given the length of our 3 sides. There is no height, there is nothing else but the length of all 3 sides. And the third scenario is when given 2 sides and an included angle. In this one, we use the 1/2 AB sine C formula. And from the example, this is when you're given 2 sides and the included angle. So let me just label this. This is A, this is B, and this is C. So it's 2 sides and the angle found at C. So that's the scenario. So when you are looking at your triangle, based on what is given, you should be able to know which one of these formulas to use to find the area of that triangle. The next shape that we would be looking at is the trapezium. And let's look at some properties of the trapezium. The trapezium is a four-sided figure. It has one pair of parallel opposite sides, and the sum of the interior angles is 360 degrees. Now the formula is A is equals to half of A plus B times H, where A and B is the pair of opposite parallel sides and H is the perpendicular height. Now let's look at the shapes. The pair of sides that are opposite, they are parallel. So that would be these two sides. Now the height, again perpendicular height, it's either given on the inside, and remember that's when the two straight lines come together to form a 90 degree, or sometimes the height is given on the outside. So in some questions you're going to see H inside and some you're going to see H outside. It's the same height that we're going to use. So let's go to an example. You have a trapezium here with two measurements and then you have the height. Now these two, they could be named either A or B. You could interchange them, it doesn't matter. So let's work with what we have, A and B. So we have A is equals to 12 cm and B is equals to 5 cm. H, which is our height, is given as 4 cm. Using the formula, let's substitute those values. So A is equals to a half of A plus B times H. A is equals to a half. A is 12 cm plus B, which is 5 cm, times H, which is 4 cm. A is equals to a half of, we add first, we work the bracket first. 12 plus 5 is going to give me 17 cm multiplied by 4 cm. A is equals to, we half this part first, and that's going to give me 8.5 cm multiplied by 4 cm. A is equals to 8.5 times 4 is going to give me 34 cm squared. And this is the area of the trapezium above. So the fifth shape we're going to look at is the parallelogram. And some properties of the parallelogram. It is a four-sided figure. It has two pairs of equal opposite sides, and the sum of the interior angles is 360 degrees. The formula to find the area of a parallelogram is A is equals to BH, where B is the base and H is the perpendicular height. And if you look here at this diagram, we have one pair, two pair of parallel equal opposite sides. So the length here and the length here is the same, and the length here and the length here is the same. So this is like a rectangle that you just take the top and you pull it across a little and it's slanted. So it carries the same properties of a rectangle. Now, again, the perpendicular height could be either given inside or it could be given outside. Whichever way it's given, that's our height once it's perpendicular to our base. Now, let's look at the example over here. You have a parallelogram with 15 cm at the top and 8 cm at the bottom. So let's see what is given. B is equals to that and H is equals to something. Now, from here I put B at the bottom, which is the base. But remember I said that this side and this side is equal. So if we're given 15 at the top, then the bottom is also 15 cm. So in this case, our base is going to be 15 cm and the height is given inside, which is 8 cm. Using the formula, A is equals to BH, we just substitute. A is equals to B, which is 15 cm, multiplied by the height, which is 8 cm. So the area is going to be 15 times 8 is going to give me 120 cm square. And this is the area of the parallelogram. The sixth shape that we will be looking at is the rhombus. Some basic properties of the rhombus. It is a four-sided figure. All four sides are equal, and the sum of interior angles is 360 degrees. The formula is A is equals to BH, where B is the base and H is the perpendicular height. And if you look here, one side is denoted as B, and then the height is either given inside or given outside. But since we have all four sides equal, this is a square that you just hold the top and you pull it across. Now, this is one of three methods to find the area of a rhombus. So let's look at this one first. And if you notice, A equals BH is the same as the area of a parallelogram, which is A equals BH as well. So this is the first method. In this example here, you're given one side as 5 cm and you have the height given on the outside as 4 cm. But if you notice, there's no base. But since we said that all the sides are equal, if this is 5, then here is also 5 cm. The top is 5 and across here is also 5 cm. So our base, which is B, is 5 cm and the height is 4 cm. Using the formula, we substitute. A is equals to BH. A is equals to B, which is 5 cm, multiplied by the height, which is 4 cm. A is equals to 5 times 4. That's going to give me 20 cm squared. This is the formula you use when you're given the base or the length of one side and the height. So we just looked at the first method of finding the area of a rhombus. Now this is the second method. The formula is A is equals to a half D1 times D2, where D1 and D2 are diagonals. And if you look at the shape here, diagonals is the line that goes from this point to this point. It is what we call D1, and then this is what we call D2. So let's look at the example. You have a rhombus here and you have the length of two diagonals given. So the first one, we call it D1, and we're going to say, and that's given as 8 cm, and then D2 is given as 6 cm. So using these two diagonals, we're going to substitute into the formula. A is equals to a half of D1 times D2. A is going to be a half of D1, which is 8 cm, times D2, which is 6 cm. A is equals to a half of 8 times 6 is 48 cm squared. A is equals to a half of 48 is going to be 24 cm squared. So when you're finding the area of a rhombus, given the two diagonals, we usually use the formula A is equals to a half D1 times D2. So we looked at two methods already. Now this is the third method of finding the area of a rhombus. The formula for this one is A is equals to L squared sine theta, where L is the length of one side and theta is the given angle. Now it's not just the given angle, it must be the angle where the angles that we're going to use is angle A is equals to angle C, and if you look here, this angle and this angle are the same, and angle B and angle D is also equal. So that's why you have one line denoting these two and double lines denoting the other two equal angles. So it's not just any angle. The angle usually come in pairs, the opposite angles are equal. Now you have an example here which one side is given and you have an angle given as well. Now let's use the formula and try to solve this. So A is equals to L squared sine theta. A is equals to L, which is our length, so that's going to be 2 cm squared sine the angle that is given, and that's going to be 33. A is equals to 2 square is 2 times 2, which is going to be 4 cm squared sine 33. A is equals to, we use our calculator and we put in 4 sine 33, and that's going to give me 2.17 cm squared. And this is the area of the rhombus when you are given the length and one angle. So we use this method when we're given the length and one angle. So we've looked at all three methods of finding the area of a rhombus. So let's do a quick recap on what formula we have to use when we're given the various shapes. So the first one is when given the base and the perpendicular height. This one we use the area is equals to BH, which is the base times height. And just a quick reminder of this. You have the shape, this is when you're given the base and a perpendicular height. We use A is equals to BH. When given the length of the two diagonals, we use A is equals to a half of D1 times D2. And a quick reminder of what this is. Our diagonals are inside. So this is D1 and let's call this D2. They could be interchanged, and then the last one is when given the sides, the side and an angle. A is equals to L square sine theta, and just a quick reminder, we have the shape, it's the length of one side and the included angle, either opposite angles. So these are the three scenarios when finding the area of a rhombus. So you look for what is given and then you apply the relevant formula to find the area of the rhombus. The seventh shape and the last shape we'll be looking at is the kite, and some basic properties of the kite. It is a four-sided figure. There are two non-vertex angles and the diagonals are perpendicular. The formula to find the area of a kite is A is equals to half of D1 times D2, where D1 and D2 are our diagonals. Now, if you look here at the kite, this is one diagonal and this is the second diagonal. Where these two diagonals meet, it forms a right angle. That means that they're perpendicular. And there are two non-vertex angles. So let's say we have this angle and this angle as our vertex angles. Then this one and this one becomes our non-vertex angles. So these are some basic properties of a kite. Now let's go into the example here. If you look, you have four measurements in this shape. Now we said that the formula is A is equals to half of D1 times D2. And we identify that this is one diagonal and this is the other diagonal. So to find the length of D1, what we have to do is to add our parts. So D1 is going to be 4 meters plus 9 meters, and that's going to give me 13 meters. And D2 is going to be 3 meters plus 3 meters, and that's going to give me 6 meters. In some cases, you would only get one length for each diagonal, but if you're given it in parts, you have to add the parts to get the length of each diagonal. So our formula is A is equals to a half of D1 times D2. A is equals to a half of D1 is 13 meters times D2, which is 6 meters. So we have A is equals to a half of 78 meters squared. So A is equals to a half of 78 is 39 meters squared. And this is how you find the area of a kite given our two diagonals. So we've looked at the area of 7 plane figures, and some things to remember from this is that area is the measure of surface, which means that we're finding the measure of the flat part of the shape. Some other things that you should remember is perpendicular height, which is formed when two straight lines come together to form a right angle. And you have to remember also the properties of all the shapes. And for triangle and rhombus, remember we have 3 different formula that we use with 3 different scenarios. Also, you have to remember when to use those formula and when each scenario is given.